So once again, the Gibbs free energy can be used to predict about spontaneity. Okay, sorry, can be used to predict about the spontaneity. So what happened in the exothermic ratios? Yeah, is it spontaneous or not spontaneous? Okay, let's take a look once again. Delta G equals to delta H minus T delta S. So if we have an exothermic reaction, that means this is negative, right? Okay, if the value of delta S system is positive, if this is positive, the second term, negative T delta S, will be negative. Okay, will be negative. And the reactions will be spontaneous. Why? Because this is negative, this is negative. So the value of delta G always negative. So that's why the reactions will be always spontaneous. Okay, now predict how if the delta S system is negative. If the delta S system is negative, the second term will be positive, right? So delta G will be negative because of delta H, and this is positive. The reaction is likely to be spontaneous if the temperature is low, because if the temperature low, the value T delta S will be low in positive value. So the delta H will be win. Okay, so the delta G will be stay negative at low temperature. Okay, but if it is a high temperature, then the value could be very, very positive, and the delta H will be loss. I mean, dia kalah dibanding T delta S-nya, ya. So the delta G will be positive at high temperature, will be not spontaneous. So now I'd like you to make the table, yeah, to show the relationship between delta H, delta S, temperature, delta G, and spontaneity. Yeah, the table will be like this. Now we want to see from the exothermic reaction. Let's say I have negative value of delta H with positive value of delta S, and then at low temperature. We already discussed just now that the delta G would be negative, yeah, and this is spontaneous. Or if we have this negative, this is positive, but high temperature. Okay, I'd like you to answer this. And how about in endothermic reaction? So the combination will be negative, 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 positive, positive, negative, negative, low, high, low, high. Yeah. Okay. Now please try to complete this table. Please pause it while you are working. Okay. Now let's continue. If you have a negative delta H, positive delta S, with high temperature, delta G will be negative, spontaneous. This is also negative, spontaneous, and this is will be positive, not spontaneous. Yeah. Okay. How about in endothermic reaction? Positive, positive. Assume this is low temperature, high, low, and high. Positive, positive, low temperature. Delta G should be positive, yeah. Positive, not spontaneous. Positive, positive, hike. Delta G would be negative. Spontaneous. Positive, negative, low. This is would be positive, not spontaneous. Positive, negative, hike. This would be positive. Okay, temperature, hike, delta S negative, so negative T delta S will be positive. So always not spontaneous. Okay, so we are done with this table. So you can see here that in exothermic reactions, the spontaneity always occur except at high temperature and negative value of entropy. Only this, non-spontaneous. Okay, non-spontaneous in exothermic reaction once again only occur if the temperature high and entropy negative. But you can see in endothermic reactions, only positive, positive, and high temperature, the reactions occur spontaneous. So the exothermic reactions is more likely to occur in nature compared than the endothermic reactions. Yeah, since only one conditions that make it spontaneous. Okay. So this is the good table, yeah, that we have just discussed. Okay, now let's practice. Calculate the Gibbs free energy change for the decomposition of zinc carbonate at 1200 Kelvin. So delta G equals to minus T delta S. Delta S is okay, so this is not spontaneous, yeah, not spontaneous at 1200 K. Sorry, spontaneous. Negative. Sorry. Yeah, my bad. So negative, that means spontaneous.